Assalamualaikum and hi everyone. Today I will present you about our topic, which is humidity chart. This is my group members Nur Aisha binti Ayub and me Nurul Aina Najwa binti Ruslan.
Assalamualaikum and hi, my name is Nurul Aina Najwa binti Ruslan. So today I want to present on how to read humidity chart. Okay, first identifying the axis. Look along the bottom of the chart to find the dry bulb temperature. The horizontal or x-axis of the chart denotes the various temperature readings in Fahrenheit or Celsius. Use the vertical lines extending from this axis to trace the measurements throughout the chart. Each label temperature will have one vertical line extending from the axis. If the measurements that you are looking for is between the label temperature, estimate its location. Second, find the humidity ratio label on the right vertical axis. The vertical or y-axis of the chart marks the amount of moisture per pound or kilogram. Use the horizontal line extending from this axis to trace the humidity ratio throughout the chart. The humidity ratio is sometimes referred to as the mixing ratio, or we call as absolute humidity. Third, locate the uppermost curve line on the chart to find the saturation curve. This curve connects the x and y axis and marks the relationship between temperature and absolute humidity when the relative humidity is given 100%. Along these lines, note that wet bulb temperature and the dew points are always equal to the dry bulb temperature. Fourth, follow the interior curve line to see various levels of relative humidity. On the chart, you will notice various lines that follow the curve of the saturation curve. This marks the relationship between temperature and pressure when the humidity is less than 100%. In most cases, each line away from the saturation curve represents a 10% decreases in saturation. Notice that as the temperature decreases, the relative humidity lines become closer together until they are nearly interchangeable. Okay, next, for the interior marking, first look on the right side of the chart to find the vertical dew point lines. Just to the right of the y-axis, find the line with the dew point measurement in degree Fahrenheit or Celsius. If you're having trouble seeing the lines on the chart, use a ruler to align the hash marks with the line on the chart. Since the lines for dew point remains constant and flat throughout the chart, the dew point does not change according to the dry bulb's temperature. Next, locate the vapor pressure line to the right of the dew point lines. Next, to or along the same vertical line as the dew point measurements, there will be marking denoting the various vapor pressure in inches of mercury or millibars. Again, if you are having trouble following the lines on the chart, use a ruler horizontally to align the hash mark of the vapor pressure with the line on the chart. Okay, then identify the diagonal specific volume lines throughout the chart. The specific volume of the air tells you the amount of air that this charge was meant to measure, normally within a range of 2 until 3 meter cube per kilogram of Fit3 or IB. As the relative humidity increases at certain temperature, the specific volume of the air also increases. Okay, last but not least, find the diurnal enthalpy scale surrounding the chart. Around the extreme of the chart and just outside of the saturation curve, look at the diurnal scale, which represents enthalpy in BTU per pound of dry air. Use a ruler to extend these measurements into the chart. That's all from me. Thank you.
Assalamualaikum, I'm Nur Aisha binti Ayub and will explain the example of problem based on humidity chart. In this problem, we will start with the air temperature of 90 degree F and a relative humidity of 50%. We will figure out the mixing ratio and the dew point temperature. The problem is worked out in detail below. First, you will fill the air temperature and the RH data that are given. Since you know the air's temperature, you can look up the saturation mixing ratio 30 grams per kg. Then you might be able to figure out the mixing ratio in your head. air that is filled up to 50%, its capacity could hold up to 30 grams. Half of a 30 is 50%, that is mixing ratio, or you can substitute into the relative humidity formula and solve for the mixing ratio. The detail are shown above given. Finally, to determine the dew point, we will imagine cooling the air. The saturation mixing ratio decrease, the mixing ratio stay constant, and the relative humidity increase. In this example, the RH reaches 100% when the air has cooled to 70 F. This is the dew point temperature. We can use the result from the humidity problem, #1 and #2, to learn useful rules. In the first example, the difference between the air and the dew point temperature was a large 55 F and the RH was low 20%. In the second problem, the difference between the air and the dew point temperature was smaller, which is 20 F, and the RH was higher, 50%. The easiest ways to remember these rules is to remember the case where there is no difference between the air and the dew point temperature. The RH that will be 100%. Okay, next example is in this problem, you are given a mixing ratio of 10.5 gram per kg and a relative humidity of 50%. What are the air temperature and the dew point temperature? Here's the play-by-play solutions to the questions. First, the air contains 10.5 gram per kg of water vapor. This is 50% half of what the air could potentially hold. So the air capacity, the saturation mixing ratio must be 21 gram per kg. You can either do this in your heads or use the RH equation following the steps shown. Second, once you are known the saturation mixing ratio, you can look up the air temperature in a table. 18F air has a saturation mixing ratio of 21. Then you imagine cooling the air until the RH become 100%. This is occur at the 16F. The dew point is 16F. That's all from me. Thank you.